I thought I'd make a short video to show you how to solve one of those ANOVA table quizzers. The link has been in our Blackboard site. And somebody might also wonder, why would you want to do this, other than the fact that it's a little bit like those Sudoku puzzles? And the answer is that one of the very best ways I know of to remember the relationships among all of these components of analysis of variance is to learn how they work in this table. And I've given myself a little bit of an Excel spreadsheet over here on the side so that I don't have to do the math in my head, but you will be able to see me do it. So this is a one-way ANOVA, and I picked the easy level of table. And as you can see, there's also medium and difficult, but we'll just start with easy. And so the first thing we can do is add up the parts that add up. So we know that between and within add up to total, and that's true for both the sum of squared deviations and for the degrees of freedom. And the degrees of freedom I can do in my head. 3 plus 56 is going to give me 59. But I think I'm going to use my Excel spreadsheet just to make sure that I get it right. So I'm going to put in an equals, and then my first number, 2635.8, plus my second number, 2139.2, and when I hit enter it's going to give me the total, which is 4775, and that makes sense that it comes out even when I see that 0.8 and 0.2. So I've got the two easiest parts, the ones where things add up. As I go across the row, I'm dividing to create the mean square. If we remember, mean square is an average of the variability that's captured by the sum of the squared deviations, averaged across or divided by the degrees of freedom. So the top row, we're averaging across something that represents the number of groups. If we've got degrees of freedom 3, it means there were 4 groups, because this degrees of freedom is the number of groups minus 1. So to average the variability between groups across the number of groups, I'm going to use my Excel spreadsheet another time. I put in an equals, and the first number is the sum of squares, 2635.8. and a slash for my division, and I put in 3, and the number that I get is 878.6. 878.6. And then I can do the same thing for my variability within the groups. If you remember, this is the variability that's completely random, because inside a group all of the people were treated exactly the same. They got the same level or dose of the independent variable. So all of this variability is due to all the other factors, individual differences, anything else that's going on. It's the random or error component. So I'm going to put in my equals 2139.2 divided by 56, and I get 38.2. Now there's a funny thing about this ANOVA table quizzer. It gives us a space for averaging the sum of squares across all the degrees of freedom. There is absolutely no use for that number. I've been doing statistics for over 30 years, and I have never seen this number even given any place. So I usually just leave that one blank. And on an exam, I will not ask you to fill in that spot. I think somebody programmed it in who didn't really know what they were doing. So this last spot is my F ratio. This is my actual F statistic. All the rest of these were just designed to help me get there. And this is the numerator of my mean square between divided by the denominator, my mean square within. So this ANOVA table is set up in a really convenient way to make it evident how I create this ratio. And I am going to use my Excel spreadsheet to make sure I get it right. So I've got 878.6 divided by 38.2. It gives me the number 23. To find out a p-value and know for certain whether or not I had a significant result, I would need to either find a critical value of f in an appendix. for 3 and 56 degrees of freedom. Or if I were working with one of the software packages we're using this week, I would have a p-value computed along with it. But if you remember, when the null hypothesis is true, our F statistic is 1.00, and 23 is really quite a large number. So even without looking at a critical value in a table or having an exact p-value, I can be pretty certain that this would be a significant statistic at the 0.05 level and probably at the 0.01 level as well. I encourage you to do these ANOVA table quizzers over and over again until you can do them in your sleep. As you go up the scale, it makes it a little more difficult by taking out different pieces. So here I'm going to have to solve for the degrees of freedom before I can go across. To get these degrees of freedom, I'm going to have to take this sum of squares, divide it by the mean square, and the number that will pop out is the degrees of freedom. And just so you can see what that looks like, I'll go ahead and do just one. I'd do equals 6615.0 divided by 945, and it gives me 7. I feel confident because degrees of freedom have to be integers, so I'd put that in there. Once I know that the degrees of freedom are 7, I can figure out that this one would be 62, and now it's back to being pretty much like the easier one. I divide across, I can add things up, I would get my F ratio. When I go all the way to the most difficult type of ANOVA table, now I'm going to have to find, I've got rows where I've got nothing but the degrees of freedom, so I'm going to have to work backwards from my F ratio. Something divided by 168 is 2.8. I'll multiply those to get the mean square. Then I'll multiply those backwards to get the sum of squares. And you can see it gets a little bit trickier. So I encourage you to start with the easy ones. It really makes you get a good sense for where the relationships are. Move your way up to the medium ones. They're a little bit tougher, and when you're really feeling confident, head for one of the difficult ones, or maybe you want to just dive in at the challenging end. Whichever way you want to do it, this is a great way to practice learning all of those analysis of variance components. Good luck!